Okay, well, peace out. This is our talk today, What's New in JavaFX. I'm Richard Bear. This is Jasper Potts. I'm hiding behind this thing. Let me move. So we're going to just talk about some of the things that we've done in the last year in JavaFX, and we're going to talk a little bit about some of the stuff that we have coming up. We mentioned it very briefly in the keynote this morning, and now we'll go into some more detail, show some demos, that sort of good stuff. So, yeah, next slide. Okay, so JavaFX 2, we just released it a little over a year ago. I know it seems, at least, for me at least, I thought it was at least 2 years ago, maybe 4. But yeah, we actually only released the thing a year ago.
It was like half a lifetime ago. It's been a busy year and a bit.
A lot of work going on in the last year, and the year before that when we were doing the transition from FX Script to FX 2.0. And there's a lot of functionality that's already in the platform. From there's an application class and basic pieces that will be growing for frameworks and things like that. Windows and pop-ups, the HTML5 support. We've got WebKit that's integrated into JavaFX. Audio, video, a bunch of controls. We did a bunch of sample applications. A lot of people, I think because you have to download it separately from the SDK, we run into people all the time who haven't run or seen some of the sample applications. Documentation binding. There's just a ton of things that we've done at the time that we shipped 2.0, which was a year ago.
One of the cool things we've done since is the Ensemble sample app for all Mac users is now available in the Mac store. So you even have to download the zip file. You can just go to the App Store and type Ensemble and download and install it.
Because everybody's on a Mac, right? Well, there's a couple back there anyway. Go ahead, next slide. So that's great. We had a bunch of stuff. Obviously, there's a bunch more stuff to do. What have we done in the last year, which is the main subject of today's talk. So we go ahead and hit it, and let's just sort of walk through and talk a little bit about each one of these things. So why don't you tell us a little bit about Canvas?
Sure. So this is one of the things that I sort of begged for. It was one of my sort of P's was having more control over drawing graphics. The scene graph is great, but there's certain use cases where it doesn't suit. And the classic example of this is particle systems and things like that. Anywhere where you would like to keep your existing data and then draw on top of it. A radar plot. I think it was like 2008, 2009, DevOps. Somebody came up to me and said, I really love your stuff, but I want to plot like 2 million dots on a radar plot, and then keep adding more and more dots to it. And at the time, we didn't have a solution. So, Canvas really helps us with that one.
Yep. Pixel Reader. It's basically giving people access to be able to read the pixels out of images that they've loaded.
Yeah, so there's lots of cool stuff we can do with some of these things. Writable image again is giving you the access to draw pixels in. I was writing a color picker and was trying to work out how to make a hue saturation chart, and had to use a complex gradient with 256 stops. But this allows us to do all of those sort of things and image manipulation. We'll show some examples later.
So Snapshot is a capability where you can take any sub-portion of the scene graph or the entire scene graph, and you can render it to an image. And then once it's in an image, you can stick it somewhere else in the scene graph, or you can export it to the file system or whatnot.
So this is something that I did a sort of small example of in Ensemble for the first JavaFX 1, and it was something that people liked and wanted more of. So we did it properly as a team and added the stacked bar charts and area charts to the platform.
Color picker.
Another one of those little things that people have been asking for and stuff. Just sort of filling out those missing pieces that make it easier for you to build applications. Pagination is another one of those. And there's lots of use cases where you want to have paginated content like PDFs, images.
Right. So pagination, well, we'll show an example of it a little later in the presentation.
Directory choosing, another one of those really useful things that we didn't have in Swing and always wanted.
Right. So I think SWT support. I think we may have announced it at DevOps last year, or it was the month after. It was about December or so last year that we added support for SWT. So you can embed JavaFX inside SWT or inside Swing.
So HT64, another was things that we were sort of begging for because if you want to play media that's available on YouTube or Vimeo or any of these sort of sites, any standard form or parlays, we're playing around with some parlays clients. So yeah, all internet sites are pretty much standardizing on H.264. So yeah, if you want to play video media in the modern world, H.264 is the way to go.
And just about like all the webcams capture it. Most of the your physical cameras.
Yeah, it's well on its way to being the JPEG of the media world. So yeah, it's a great thing that we can now support that and play H.264.
So the JavaScript to Java that we talked about before. So because we've got a WebKit that's integrated into JavaFX, you can host any web content that you like there. And we had the ability for Java to call into JavaScript and manipulate the page. But now you can also register Java objects with the web page so that it can call back out into your Java code.
Yeah, I had a use case of this I was trying to do early on, which was I had a Google Maps embedded, and I wanted to be able to know when you click on one of the pins in there and get an action event back into the Java side, so I could show a popover or something like that. So now you can do all of those sort of things.
So there's a whole pile of other things that were added. Observable sets that complement our observable map and observable list. Checkbox tree cells and checkbox table cells and so forth for all the little cell customizations that were done outside the platform, actually in the DataFX project, and then brought in. Just a bunch of utilities for talking to Swing or SWT for converting image types and a bunch of other things. Whole pile of things. But that stuff actually was the minimal amount of stuff that we did for this release. Most of our time was spent getting the Mac and Linux GA releases out. So we had a release in, whatever it was, March last year, I think, for Mac. And then Linux was earlier this year, is in August. And we got at Java 1 the Java 8 embedded Linux developer preview, which is what we had running here on the
and what you
kiosk.
see on the pies and that sort of thing.
Yeah. So the primary thing that our position on it is that the value of Java has always been being able to take your application and your development experience and run it on a whole variety of different devices. And that's obviously one of the highest priority items for us on the team, is to get ports to everything.
Yep. Keeps us entertained. So, Canvas is my favorite thing, so we can look into a little bit more detail.
Well, one thing that I think is worth pointing out is that when we were designing Canvas, we didn't, we took a look at the HTML5 canvas, and then we said, okay, much of this will be directly applicable to what we're doing, so we'll just keep that so that it's relatively easy for you to take a demo that was written on HTML5 canvas and run it in the scene graph canvas. But we made some changes on things to make it much more powerful, because that's what we do. And also to integrate better into the FX world.
Yeah, there's a few sort of impedance mismatches between the way the HTML canvas did it and we did it. For one, they had a weird rendering order of back to front rather than front to back, and those sort of bits and pieces.
They also weren't as powerful when it came to things like what kind of paint you're going to use to draw.
Yes, yeah. So, for example,
kind of a ridiculous limitation.
Everything you draw can be a gradient or a image texture fill or a solid color in JavaFX. We have some pixel manipulation stuff. We have a few new bits and pieces. One of the big things we added was effects. So in JavaFX, we've got all these effects like drop shadows and reflections and displacement maps and sort of complex things like that. So you can actually use all of those in Canvas. What we did actually, which we desperately need to release, was we actually did a simple class that makes it very easy for mapping HTML canvas over. I meant to get that as a sample, so I'll work on getting that out to you. But that allows you, pretty much direct porting of HTML canvas examples over to Java's FX canvas. So let's have a look at some code. So here we got our canvas. So basically, canvas is backed by an image, or in our case, it's a texture inside the graphics card. So we have a texture. In this case, it's going to be 1024 by 500, and then we allow you to draw into that. So the first thing we're going to do is going to set a blend mode. That affects every pixel you draw from this point onwards, or every draw command is now going to have that blend mode applied to blend that draw into the back. Into what exists already inside of that image. So just anybody who's familiar with Swing and Java 2D, this will look very familiar, or pretty much any sort of 2D traditional drawing. So you get a graphics context out of the canvas, and you set your state. So in this case, we're going to see set a fill that we want it to draw in a transparent black in this case, and then we're just going to fill the entire canvas area with a transparent black. And then we're going to set the overall alpha of how transparent we want to draw things to some sort of random amount, set a different fill, and draw an oval, and so forth. So it's just classic 2D drawing stuff. So the end result of all that was I was talking about classic sort of particle systems. So this is a fun little example we did of a photograph I had of San Francisco as the background. On top of it, there's a canvas at the top half, and then the bottom half is just applying a reflection effect to the canvas.
So on each frame of the animation, you are doing a blend and dimming things out, drawing the next thing, blend, dim it out.
You see that each of the fireworks has a little trail behind it, basically. So each frame, we're only drawing the tip of that, the new firework, and then, at the beginning of the frame, we blur everything out, so we dim it all out, the previous stuff, and then draw the new one. So if we had to draw every one of these fireworks and every piece of the trail, every frame, the performance would be horrible. But as we're just adding to it and adding to it, as the firework moves, we can get great performance and handle thousands of them.
So that's Canvas. Writable image, as we talked about, right? It lets you do direct pixel bashing on an image. So you can take any image that you've loaded, and you can get a writable image from it, and then you can go ahead and draw into that thing. You've gone backwards.
Somehow I'm going backwards. Mouse with 2 buttons for a Mac user. This is scary. So pixel reader, pixel writer.
So writable image, right? You create a new writable image, and you can do what you want with it. Pixel reader and pixel writer are different ways of being able to interact with images. So all images have a pixel reader. You can read whatever the data was on there. And for writable images, you have a pixel writer that you can write directly into. So you want to create an image and reuse it elsewhere in your application. You want to use it as the texture for, as the fill, because you've got an image fill. You can use it to fill shapes, whatever you want. You just kind of scribble on in there. So here's a simple example. You get your writable image here. You get its pixel writer, and then you can just set the pixels. You can pass in an array of pixel data and so forth.
And this is great for generating sort of complex backgrounds, and some of the classic ones we do in Java 2D are things like your stainless steel look or your graphite look and things like that.
It's also great for integration with sort of random other technologies. So for example, somebody had VLC for doing all their media because they wanted to play all sorts of different media formats, and this was a way for them to be able to pump the pixels directly to the
just take graph. Each frame and take it from the native JNI call and just pump it straight into Pixel Writer. And again, somebody was doing this for embedding Swing into FX, so it opens a lot of possibilities. Last year we were playing around with the Microsoft Kinect cameras and tracking stuff, and so it'd be great for that, for taking the video feed from that camera and pumping it into FX. So this was something I sort of had a play around with. I watched a video about. I watched a video about the new Photoshop, and there's this sort of cool effect that's sort of being popular at the moment. Let me find the little demo. So in traditional photography, you have these lenses where you can move the front of the lens independently. It causes one of these cool effects where when you take a picture, you can make things look like they're a toy. So I can look at this picture, and it makes it look like it's a model of the picture with the little village in the middle and stuff. And so all you're actually doing is affecting you're blurring out the foreground and blurring out the background. So I was playing around with our stuff to do something similar. So you can adjust the amount of blur. We can move this around. And so it really allows you to start doing image editing and all the sort of complex things that you couldn't do before. We can affect our blur. So it's actually applying a proper sort of lens blur effect. blooms are cool. Start to all go a bit crazy. Oop, that's a bit too extreme. But actually, as I'm adjusting these sliders, it's reprocessing every pixel in the photograph and applying some algorithm to it. So you get a whole chance to do all kinds of fun things, which we couldn't do before. So let me flip back.
So snapshot, like we talked about, you can take any portion of the scene graph, you can take a snapshot of it, it will be in an image, and then you can use that image in any way that you would normally use in JavaFX. You can export it using Swing utils or SWT utils. You can also stick it in a scene graph somewhere, put it in an image view, or you actually could use it with an image paint. So we have an image paint that was added in, I think, 2.1 or 2.2, and which allows you to, well,
use an image as a texture anywhere. So actually on the kiosk example, the background, we have a little tiled image. And so you can actually just set the background of your scene now to be a tiled image. Or you can fill shapes and things with tiled images.
Or you could do something really ridiculous like what we're about to do here. So in this case, I've got some little scene graph, right? I've got a button, and I've got some text node. And what I'm going to do is, using a lambda expression here actually, I'm going to go and take a snapshot of my scene graph, and then I'm going to shove the image that I get from that into an image paint and use that on my text node so that it looks ridiculous. But the point is that obviously there's not a gazillion buttons behind this text node. This isn't like a clip or something. This is just simply, I've drawn some random thing, put it into an image, and then I've used that to texture some other nodes in the scene graph.
So it just opens a whole new way of sort of possibilities.
Yeah, you can do, you could even put a table view in there. I mean, I'm just saying.
So one useful example of this we've had that people have asked for before is you've got some big canvas drawing area, and you want to have a little navigation window in the top corner that shows you a zoomed out view of it with the box over showing you which piece you're looking at. So previously, you would have had to have 2 copies of the entire scene to be able to render that, and now you can just snapshot your content view and stick that in as an image into the top right corner.
Also, if you're doing any sort of, you've done a chart, you want to grab an image of the chart and export it into the file system, put it into a PDF, whatever. That's how you'd be able to do it. So here's an example chunk of code that will, save it to disk. So the first thing that we have to do is we have to find out what the bounds of the node are so that we can make sure that we get a writable image that's the right size. Then we create our snapshot parameters. We tell it what fill we want. It can have a black fill. It can have a colored fill. It can have a transparent fill, whatever. And then we call the snapshot method. And when the snapshot has completed, then we are going to use SwingFX utils to convert this JavaFX image into a buffered image. And at that point, we can use the normal image I/O from Java 2D in order to just write the file.
Yep, there's a PNG, GIF, JPEG, etc. So JavaScript to Java. So this is something we mentioned earlier as being really extending the power of what you can do. And it was something we had to think about a little carefully because it could potentially open security holes that if your web view is loading up arbitrary pages from the web and you are providing to it some Java objects or the access to the entirety of the Java APIs, you can imagine this could be quite dangerous. So the idea here, what we did was make it very selective. So you can create an object and say, I want to expose this object to JavaScript and only that object. So you have exact control over what API JavaScript is allowed to access.
And as an API designer, the nice thing about this one, next slide please, is that we didn't actually have to add any new API in order to do this. We just had to add a new capability. So from the Java side, you can already get a handle on any of the JavaScript objects that are available inside WebKit. And so in this case, you can get a handle on the window JavaScript object, or you can really get any of the objects that are in the page and find those things. And then all you have to do is just call setMember on that JavaScript object and pass it your Java object. And now all the methods on that Java object and properties and so forth are exposed to JavaScript. And from JavaScript, you can just invoke the methods. You can pass in data, whatever you want to do. So It's really, really nice, clean, tidy, works real well. So something that Jonathan was working on the JavaFX project with some other guys was to be able to have a lot of pre-built cells for all the different UI controls. Obviously, when we first shipped, we had, well, basically just the built-in cells, and that was it. But there's a lot of things that are typical. Everybody wants to be able to display Booleans with checkboxes, to have editable text, to have choice boxes or combo boxes inside of list trees, tables, and so forth. So we added a bunch of API for that.
Yeah, maybe next time we'll get charts. That could be fun, charts inside table cells. So pagination is something that we mentioned earlier. It's basically much like a table, a tab pane, that it's multiple pages of content and a way to switch between them. And the big difference is that tab pane has all of the nodes and everything created for every tab up front. You can hook in and change that, so you can actually get events and add and remove nodes as the tab changes. But by default, it creates all the content for every tab up front. It also has limitations on how many tabs are practically possible. We've seen this with browsers and IDEs and stuff. If you get too many tabs, it gets a problem. So pagination allows you to have different views onto the same sort of tabbed paged content, and also have an arbitrary number or potentially an infinite number. So a great example of that is search results. You go and you search on Google, it gives you a potentially infinite number of search results. You don't necessarily know how many answers, or you do a Lucene index search, you don't know exactly how many answers are going to be, how many pages that's going to take. So you can have an infinite number of pages, and generally you only get through the first few.
So we're going to look at a little code for how you can use the pagination. You create your pagination object. The first thing I'm doing here is I'm changing its style class. So this is a pattern that we use in a few different places inside JavaFX, which is that we have a couple built-in differences in appearance, and we have a public static final string that represents what the style class is going to be for this thing, and then we style it differently from CSS. So in the pagination, you have two different built-in looks. One is basically boxes with numbers and little arrows, and then the other one is you're going to have little bullets instead.
Yeah, if you look at the Apple.com homepage, they often have this thing where they have some image of a product, and then you can swipe or click on it and go through a bunch of them, and there's little dots to represent where you are in those number of images.
Exactly, and then the next thing I'm going to do is I'm going to set what the page count is. In this case, it's 7, but it could be max value or whatever. You can set it to what the value is that you want. Now, the next part is that we have to register a callback, and this is our page factory. And what's going to happen is whenever the pagination control needs to go to a new page, it's going to give us a callback and say, I need the nodes that represent page N. And so you can create and then return those nodes from here. And when it's done with them, they'll get garbage collected, and you'll create new ones and return them and so forth. So this is how we can handle just some arbitrary number of pages.
And it works really well for the embedded devices where you just don't want to keep that much around in memory at one time because you've limited resources. So
I think we have an example here of just the sort of thing that you were talking about that Apple often do. So we've just got some nodes here that represent the stuff, and then we've got our pagination control. And I hooked it up to a timeline so that it would advance what the current page is, and is all very easy.
And all the animation is built in.
Yeah.
And also, if you have a touch device, a Windows 7, 8 tablet, then it supports swiping as well for switching between pages.
Oh yeah, combo box. It seems like forever that we've had a combo box, but actually it's kind of new.
Yeah, it's one of those things that was probably on people's most wanted list for a long time. We had choice box to start with, which was your classic menus, your list of limited list of choices.
I guess it's classic for us because it's a very common idiom on Mac.
Yeah.
So when we were looking originally, we were looking around, and on Mac they have very few instances of combo boxes. Almost everything's a choice box. They just sort of designed it that way. So choice box was the first thing that we did because we use a lot of Macs. But obviously from the Windows side, almost everything's a combo box. So anyway, we've got a combo box now. So it can be editable or non-editable, and obviously combo box is designed to handle arbitrarily long lists. It's just a classic text field and list view combination. So here's simple usage of the combo box. We created a new combo box. We set the items, which in this case are going to be fonts, and it's just a list of items. We tell it that it's going to be editable so that you can type in different names of fonts, and then we've got a cell factory. Now the combo box is much like a list view, table view, and tree view. It's got cells that are used to draw each one of the different items. And so in this case, we're going to set our cell factory so that the text that we show has whatever the font is that you're trying to represent. You can do anything arbitrary inside of a cell that you want.
So stacked bar chart and stacked area chart. These were just sort of two of the sort of missing chart types. We're slowly working on sort of extending the charting functionality. Charting is one of those huge domains where I think we could spend the rest of our lives adding chart types. But hopefully we'll get a pretty useful set, and these are very handy ones. So here's an example code of what you need to do. So we have the two axes, an X and Y. We then just create a stacked area chart, giving it those two axes. In this case, we're just plotting numbers against numbers. We can set the title for the chart. So we then create a data series, and then for each of the series, we add some data. So the big difference between a classic area chart and a stacked area chart is the distance between the two lines is the value, rather than the distance between the line and the 0 mark. So an example of this is you have something trending over time, like the number of people attending DevOps from each country. So each series would be representing the UK, Spain, France, etc. And then the total height of the entire chart would be the total number of attendees. So rather than, it allows you to both compare how, whether there's less people from the UK than there are France, but also compare over time how the overall trend of attendees was.
And of course, just like with all the other charts that we have, you can dynamically change the data values or what the data items are, and it will animate and do everything for you. And it can be completely styled from CSS. All the different colors, everything is styled from CSS. So H.264 and HTTP live streaming. So we always have been able to play the MP3 audio, but we added the support for H.264. Now the way that this works is if you have the codec on your system, then we'll be able to play H.264, which happens to be on every Mac and every Windows Vista 7.
Yep.
And
so if you XP,
machine.
you need to install the Microsoft H.264.
Yeah, which
codec.
might be a good time just to bring up, in case you don't know, that Java 8, not just JavaFX 8, but Java 8 is not officially supported on Windows XP. Microsoft has got to end of life. They've got past end of life. They've got to like really, really, really past end of life on Windows XP. And we have a policy that we don't support platforms that the OS vendor themselves doesn't support anymore. So just so you know, what that basically means for the H.264 support is it's on all Macs and Windows out of the box. Nothing to worry about when it comes to Java 8. So you don't have to do anything really to make it work except just point it at an MP4 and it plays.
Yeah, or an H.264 file, either of the containers.
So I think we've got a short demo. So how did we get this video? We downloaded it from where did we?
Yeah, I think
we got it just from Apple's trailers.
Yeah.
You go download the image.
So the idea is, one of the big things with H.264 is you can just go and get videos from any source, play any standard media. Unfortunately, we haven't connected up sound, so we'll see how this works.
That's all right. Hold your cheek down. But
yeah.
Yep.
Yeah. So this is a full 1080p video playing in FX. We just have some simple controls. Right.
You got to find your Mac. Yeah, there you go.
Whee. So that was one of the things we added recently was a full screen mode for Macs, which is nice for all the Mac people.
So that's HT64 support. So that was a sampling of the things that we've done in the last year.
Yeah.
And then we're going to talk about, just briefly here, a list of some of the things that we're doing for JavaFX 8. First one on the list was 3D.
Yeah, I'm so looking forward to playing with this some more. You would have seen that if you were in the keynote a little bit earlier, the Navis Canoe demo that we showed, where we're doing a 3D dockyard. I think 3D is a lot of fun, but it's also going to be a lot of really interesting business use cases for it. It gives you slightly more direct access to the GPU. We're still going to do it in a very FXy way. The idea, we want to make 3D as easy as possible for you. So, we want to be able to do something like, new cube, set color red, set fill red, and then you'll get a nice looking red cube.
And of course, you can style that from CSS.
And yeah, you'll be able to start from CSS and do all of those things. So we're hoping to make 3D, easy for everyday developers, that you don't have to understand how a GPU works or the pipeline or any of these sort of things, or OpenGL or DirectX, to be able to do 3D stuff.
But at the same time, we want to provide enough support that somebody who knows a lot about Maya or doing animations and character animations, things like that, will be able to produce stuff that can be used inside JavaFX. So, but it definitely is true that we're trying to make 3D accessible to people like me.
Yeah.
Who have no idea what I'm doing. Now, the next item on our list was accessibility, which unfortunately actually is not in JavaFX 8.0, but we're hoping that it will be in the one of the follow-up update releases of Java 8, JavaFX 8. Bidirectional text, is actually pushed, I think, now. So it's in the...
Yeah, so one of the things we haven't mentioned, so along with OpenJDK, you can just go to the, I think it's just at the OpenJDK site, and download the latest 8 builds for JDK 8. They include JavaFX 8. So the latest builds of 8 include the very latest JavaFX. It's about a week later than we write the code. So we write the code, check it in, and you guys can play with it a week later. Sometimes it's as little as 3 days. So really you can go and play with this stuff now. As soon as a feature is generally ready, it will go in, and then it will be finished off in there. So BiDi is already in there. Rich text, which we'll talk about in a bit, is already in there. Or it's just about to arrive, I think, next week or so.
Well, I think it'll be in the dev builds next week.
Yeah,
but
so
it's in
really
our
close.
repos now.
3D, hopefully in the next couple of months, and so forth. So keep an eye on that. Please download it and play with it, and send us any feedback. The earlier you can get feedback in, the bigger chance that you might actually influence and change things. So.
Yep. So some other things that we've been adding is, for example, we changed the hierarchy of control, so that control now extends from region. The upshot of that being that you can do a bunch of styling of the control directly actually from code. So one of the APIs that we added a month and a half ago or so was some API so that you can do all the styling that you would normally be doing through CSS directly on the control itself. So you can set its background fill and so on and so forth directly in code. And because control now extends region, it gets that behavior exposed publicly. Yeah,
one of the other big advantages, working with embedded devices, was it allowed us to reduce our node count for like a table by 30–40%, which is a big gain when you're dealing with small resource limited devices.
Yeah, because instead of having a control and then having a skin node that was a region and then a skin node that was the text or whatever, you could just do control and text, and that would be it. So the structure of the nodes, the skin implementations has changed as a consequence in order to reduce the number of nodes and increase the performance. And we spent a lot of time leading up to Java 1 working on performance and made some huge gains. Just about across the board, 2x performance improvement on everything.
Yeah, and some things just
some
huge.
of them were way more.
And from low-level performance improvements, like I think we got a 5x performance improvement in just a filled rectangle by improving our shader code that's running on the GPU. We put in a optimized path for gradients that only have 2 stops, as opposed to dealing with the generic way. And I think that's giving a 2 to 5x improvement on gradient filled shapes. We have a native rasterizer for paths. we just did a huge amount of work across the board to improve performance.
Yeah.
Some caching stuff in regions, one of Rich's pet projects recently.
It broke everything.
Yeah.
But it's fast. Yeah, so there's been a lot of good work going on the performance side, and it's really, you know, because we were working on the embedded systems and they are such limited devices, they found a whole bunch of things that we probably would have taken us a lot longer to figure out, but once we made those changes, they had huge impact on desktop as well.
Yeah, it's just
really
kind of a
smooth.
pleasure going back to desktop, but now it's just like so blisteringly fast. It's fun.
It works really well. So we're also doing some work on the third-party control side in terms of making it easy for people who want to write controls in an ecosystem to be able to do it on this sort of the same playing field that we are. So there's some things that we're doing for that in 8.0. There's more that we'll be doing in the update releases following that, so that within the JavaFX 8 lifetime, we're going to have all the third-party control ready stuff. We have a new version of Scene Builder that's coming. We haven't actually demoed it at Devox. Or at least I haven't. You did last, no, not yet. So we haven't demoed it yet, but Scene Builder is actually a phenomenal tool. If you haven't had a chance to play with it, it's really a pleasure to use. And basically, Scene Builder allows you to drag and drop and do all the layout in a visual way. It is manipulating the fXML files, so the XML description of your UI, which then has, you know, a Java controller, or really you can use any language you want as the controller for the thing. And anyway, the Scene Builder allows you to do that very, you know, graphically, and has some great support in it.
And it's all written in FX as well, so you know it's a large, you know, enterprise-level application written in FX.
Yeah. So we're going to talk a little bit about rich text in the remaining of the slides. Because we had some time shortened, we'll probably cruise through some of these things very quickly. But I wanted to go through some of the rich text stuff. This is something that obviously has been requested a lot, and I wanted to sort of explain a bit how rich text fits into our APIs. And this should be available, if it's not this week, then next week in the developer preview builds. And like Jasper was saying, right, JavaFX is co-bundled with Java. If you get Java 8, you're going to have JavaFX 8. If you get Java 8 developer previews, you're going to get the JavaFX 8 developer previews. It's all together. So that's how you get the latest stuff that we have. So rich text. There's a bunch of different use cases. You might be wanting to write a text editor. That would be my most common thing. I was trying to do a mini rich text editor for some enterprise use cases. Or maybe you're doing a code editor. Or maybe you're doing just in labels. You want to have some of it bold and some of it not bold. Extremely common, right? For buttons and cells and labels. You might be doing like headings on a page. You might be doing descriptions on a page, sort of more of an HTML-ish sort of a layout. Large blocks of textual content. There's a lot of different places where you might want to use rich text. So what we've done is we've created a new container. In fact, just about the only new API in the entire thing is this thing called a text flow. And it's just another layout container. Just like a flow pane or a grid pane or any other, you have a text flow, which is a new layout container. So here's some example code that is going to do a little bit of rich text. I've got two different fonts that I'm going to create. One is just a normal 96-point Helvetica. The second one is a bold 96-point Helvetica. Then I'm going to create two text nodes. The first one's going to say hello, and it's going to have the regular font. And then the second one's going to say world, and it's going to have the bold font. Then I just create a text flow, and I give it these two text nodes. The text flow is going to be responsible for taking the two text nodes and, well, flowing them into a single thing. So we have a hello world. Now, text is just a node. It's a normal node in the scene graph, which means that you can do anything to these text nodes that you can do to any other node. You can add effects, event handlers, animations. So here's an example. We are going to create a different text node for each letter in this, this title, Goodbye Cruel World, right? So I'm going to call this method called letters, which is going to take this text and is going to create a list of text nodes from it. And then I'm going to create a text flow, and I'm going to add all these nodes to the text flow and, position the text flow. And then, and here's the method that was creating it, right? It takes a string and it takes a font, and it just iterates over it and creates new text nodes. Nothing fancy. And then what I'm going to do is I'm going to set a mouse click event handler, again using a lambda expression here. And on click, I'm going to create a new sequential transition that's going to be made up of animating each one of those individual little text nodes. and here's the chunk of code that actually creates the animation, right? So it's going to sort of randomly assign different transitions to each one of the different letters. Now these transitions are sort of pre-canned. They aren't in JavaFX itself, but they're on FX Experience. We've got a FX Experience tools project on GitHub that you can go and download these animated transitions.
And FX Experience is the joint blog with Richard and I and Jonathan Giles.
Yep.
So
here it is, and hopefully it just starts animating, or do I have to hit a button? Goodbye, cruel world. So here you get just sort of random animation. So we had rich text, but also because all these guys are nodes, you can do anything you want. You can translate them out of place, and so on and so forth, using all the same rules, conditions, idioms, everything that's available in JavaFX for normal layout. And of course, since it's just a node, you can use CSS too, of course. So obviously this is just like the web, right? I mean, one of the philosophies that we had was we were designing JavaFX. When we're designing APIs and also just the general architecture, how we're going to put this thing together, was to obviously look around and say, well, okay, what did Swing do? What did SWT do? What did the web do? What did so on and so forth? And there's a lot of wonderful things that were done in the web, and we wanted to bring those things into the platform. And CSS is a huge integral part of how we build our stuff. And the scene graph is similar to a DOM hierarchy, except a heck of a lot better and nicer to work with. And so we get to take advantage of CSS in exactly the same way that you would do it in HTML. So we create our text node, we give it a style class. We create another text node, we give it a different style class. We add those text nodes to our text flow. If you wanted, you could think of a text node as being a span and a text flow as being a div. That's essentially what we're looking at here, right? And then in our CSS, we can just say, well, if it's got the style class regular, I want to give it 96-point Helvetica. If it has a style class strong, you can give it a bold 96-point Helvetica, and heck, fill it with red. And you'll end up with hello world, completely styled from CSS. So at the time in your code, it's just unstyled, hello world, but from CSS, you can style it however you want. And because text and text flow are just nodes, you can use it from FXML, which gets you even closer to looking like HTML. But it also means that this can all be worked with from Scene Builder. So we can specify what style sheet we're going to use with this thing. We can specify that we're going to have a text flow. Again, it's much like a div, right? I can give that a style class, and then different text nodes inside the flow. Again, sort of like a span, and I can just put the bits in there, give them different style classes, and I have my associated CSS. You'll notice that in this CSS, we're taking advantage of all the JavaFX power that we've given to our CSS engine. So not only can you specify the font, but you can specify the fill, and the fill can be a repeating image pattern, which is going to do a texture fill of this particular guy, and we can stroke it, and so on and so forth. So now when we come look at it, we see that we've got some texture pattern applied to the bold word, and it's got a stroke, and we've given italics to the word world, and so forth. So you can completely style your rich text from CSS. So, one question that we had was, well, why did we even need to add a flow pane? I mean, we've got why do we have to add a text flow? We've already got a flow pane. What's the difference between the two? Well, one of the basic differences between the two is something that I'm going to show you here. So we've got a bunch of different text nodes here, and we've given them multiple different style classes, and we've got multiple different words, and they're all put together. Yeah, whatever. And the CSS we don't care about. We really don't care about. I mean, I'm serious, I don't care about CSS. But this is what it looks like in the end, right? So I've styled this whole thing. Now the important thing is, notice fancy underline. This is actually a single node that has been split into two pieces in the flow in order to make it look right. And that's just something that flow pane is not designed to do. Flow pane just treats each node as a box, and it just puts one right after the other. The text flow knows things about text. So not only does it flow the boxes next to each other, but it will also cause a text node to draw in two different disjoint locations if it needs to. Or, as we can see here, I'll skip that, you've got a ligature that's constructed from Arabic, but it was actually as specified two different text nodes, one that was green, one that was magenta. But when the sequence of those characters are next to each other, it's supposed to have a special ligature for Arabic, and all that survives. The text flow is able to handle all those use cases. So the text flow support that's added now to JavaFX 8 supports BiDi, complex text, and rich text all in one shot. So you just create your text nodes, you specify what the language is in terms of right to left or whatnot, you set it on a text flow, and it does everything else for you. So like I said, text pane is just a layout container. It's just a parent. And in JavaFX, according to the API, that means you should be able to put anything into that layout container. And in fact, you can. So here we've got text nodes, and we've got a button and some more text nodes. And we've styled everything, it's wonderful. And it lays it all out. Now, not only does it lay it all out, but you'll notice it's also laid it out according to the baseline. So any node that you stick into a text flow, if that node defines where the baseline is inside that node, we will lay it out relative to the baseline of the text that's on that line, and we'll shift everything around appropriately. So you can literally, this really isn't magical, right? This is like basically HTML. Yeah, basically. You can specify a DOM, if you will, which is our scene graph of nodes, which include text and other stuff like images or buttons or whatever, and it'll flow it all and do the right thing. Yeah, so that's great. So that was basically just a quick tour through the rich text support that was recently added that we'll be able to play with. And because everything is a node, you can get the bounds of everything that's on there. You can draw overlays. You can do really anything you want. You can translate them, animate them, add effects to them. Really, there's a ton of stuff that you can do.
It was something I desperately wanted when doing helping with the tweet walls that are running in between sessions here. You'll see was we've got lots of complex data, text, content, and images to lay out, and having the rich text would have really helped. So I can't wait for it to get in.
Yep, that's good stuff. So we're back to where we started, which is a big list of various things that we've added within the last year, and also we're standing here next to our kiosk, which represents all the things that we're going to be working on in the next year. There's a bunch of additional little APIs, but again, one of the primary things that we're focusing on right now is porting. And part of the porting process is going to be performance. So performance and porting is a big part of what we're going to be doing in the next 8 months.
Yeah, and as we mentioned, I think in the keynote that we have a build out at the moment for Beagle boards, but hopefully we'll have one for Raspberry Pis really
Very soon.
Yeah. We're working hard on that at the moment. And each of these little boards is their own little world. They have their own graphics drivers. A lot of them have their own variation of Linux distributions and so forth. So it's a reasonable effort to go through porting to all these devices, but that's something we're working hard on at the moment. That's one of our big tasks.
Another thing that we're doing for the Raspberry Pi, incidentally, is that just about everybody who's provided some sort of a GUI platform for the Raspberry Pi has been soft float. Now, the Linux build that's on there is a hard float. The difference is that in soft float, you're emulating floating point stuff in software. Hard float, you're actually using the hardware support that's built into the Pi. So that's what we're going to be delivering is hard float support of JavaFX on the Raspberry Pi. Not a lot of people are doing it because the Raspberry Pi actually has an ARM v6 chipset, which is very old, and pretty much Pi is the only thing that's using it in a widespread manner.
Yeah, it's pretty
so
much
a lot of folks aren't doing it, but that's what we're going to be doing. So it should make JavaFX really nice to play with on that $35 Pi.
Yeah. The one I'm dying to do is at home. I've got a sprinkler system. Living in California, you have to water things. In England it just comes out the sky, but in California, you have to water everything. So I really want to have a nice control system for the irrigation, and maybe have some sensors in the ground that can take back humidity and stuff and feed that back in. So I have a
Raspberry Pi,
Raspberry Pi and a nice touch screen, and this could be some fun.
You'll be able to turn on and off sprinklers by hitting the stuff. There are a lot of cool sort of hack things that we can do. So with that, we've got a red screen down below that tells us that we have 5 minutes. So you can ask any question you want. Even ask like the hard questions that we've dodged.
I'm interested in tree table and component orientation.
Oh yeah, so Jonathan's very interested in tree table and component orientation. So component orientation is part of the BiDi support, right, which will allow us to render our stuff on the other side. And in fact, it's mostly working. Leif hasn't quite pushed it into the repo, but We're using a technique similar to the way SWT did it. And yeah, so that's coming along nicely. And you know, one of these days, Jonathan's going to get the tree table put in. But tree table is going to be part of JavaFX 8. So that would be nice. Yes?
This text flow you showed, does it support justification?
Oh, the text flow support justification, yeah.
Left, right?
Left, right, center. And I don't know if it does full. I have to check with Felipe. But yeah, you can give it justification. Tell it which way to be. Oh, when are we going to rewrite NetBeans in JavaFX? Yeah, well, that's a good question. So honestly, right, this is actually a very good question because I did not bring this up yet at Devoxx. One of the other big features that we are working on for JavaFX 8 is to be able to embed Swing into JavaFX. Now, right now, you can do it the other way around. You can embed JavaFX into Swing, but you can't do it the other way around. Not only that, but the embedding is kind of lousy because there are different threads. You got the Swing AWT event dispatch thread, and then you've got the JavaFX application thread, and they're two actually separate threads. So whenever you're talking from Swing to FX, you always have to do a run later or invoke later, depending on which way you're going, right? So we're trying to fix both the threading problem and also to allow you to embed Swing into FX. And the reason why that's critical for the question that you asked is that suppose NetBeans wanted to rewrite itself in FX. Suppose that's what it wanted to do. The thing is, NetBeans has a whole plugin world, right? And random developers, like you guys, have written plugins for NetBeans. Or maybe you're using NetBeans RCP for building your applications. And as a consequence, you have Swing code that you can't rewrite or that somebody else isn't going to rewrite, or you, the NetBeans platform, are depending on somebody else who hasn't rewritten the plugin, and you don't want to leave all that behind. So it's actually crucial that the platform support the ability to embed Swing into FX in order to have a migration path. Now, that's not to say that I can answer your question, but all I can say is that feature needs to be there before we would even be able to
In
make progress on that.
7.3, they're already using the web view out of FX. So as of, I think, NetBeans 7.3, they've started actually using FX stuff.
Well, and the big thing that we're trying to do with Scene Builder in the Scene Builder 2 timeframe is to integrate it directly into the IDE itself so that in Eclipse or NetBeans or whatever, you'd be able to just have the design environment directly right there in the IDE. You know, an integrated development environment.
Yeah, I suspect you'll see a lot of conversion in the next couple of years.
There's also some other projects, by the way, at Oracle, such as JRocket Mission Control. We've been talking to those guys because they're all based on SWT, and they're very interested in moving stuff over to FX as well. So there's a bunch of tools and things that we're doing that, you know, could quite likely see a lot more FX usage in the future. Oh, yes. Say, is the text flow control which?
Editable.
Oh, editable. No, it's not. Nope. But we will subsequently add an editable rich text control. So in JavaFX right now, the way that you get editable rich text is by using the HTML editor. So HTML editor is in the JavaFX web package, and it uses WebKit in order to do all the editing, and we just use a normal JavaScript editor. Yeah, we've done some planning around doing a text flow-based rich text editor UI control, but that won't be in this release.
But you know, I think it would be very feasible for now to use the HTML editor along with the rich text display or the web display, depending on. Yep. But yeah, the advantage of the rich text over using an embedded web view is it's a much lighter weight thing. It's a lot less memory heavy and so forth. So you know, if you're displaying relatively simple rich text, then it's much easier with the rich text facilities. Yep. So I think you could pair the two together and solve it pretty nicely.
So I think we've got time for one more question.
What industry adoption do you see so far? Professional software development?
Yeah, that's a good question. So we do have okay, it's pretty good. So within the Swing, SWT, Flex, Silverlight, we're seeing a lot of developers from across the board and companies who have been converting over to JavaFX within the last 6-8 months particularly. There's been a lot more traction in those industries because, you know, as far as it goes, right, Java is actually a really good choice for doing cross-platform development, and a lot of these other options are being disinvested from the various companies that were doing it. Obviously, we're not doing Swing and AWT anymore, really. SWT, the Flex, Adobe sort of turned that open source. Silverlight, same thing. So there's a lot of those developers who are looking for a place, and JavaFX fits really nicely into those cases. A lot of these cases are heavy, big applications, and some of these people have tried doing HTML. It's a complete non-starter for the sort of stuff that they're doing. It just doesn't work. So we've seen a lot of adoption of those. It's one of those funny things, though, where you don't see these things in your normal everyday life, right? They're not consumer-facing. They're very much the enterprise things. It's something one business sells to another business.
So train control systems, air traffic control systems,
docking yard systems,
dockyards, big chemical plants,
pharmaceuticals, banking.
So all of those sort of big industries are sort of looking at it, and we know with the Navis guys, they actually had a team, tried HTML, didn't work out. They couldn't do the sort of visualization with the large data sets that they were dealing with. And something we can help them out with FX. So there are cases where HTML5 doesn't solve every problem. We can help out.
And I think cases like what Stefan was doing is a perfect case for doing HTML, right?
Yeah.
You want to run it inside the browser, HTML5 is a good choice for you. If you're trying to write a desktop application or you're trying to write a kiosk sort of application or whatever, man, you want the performance, the stability, and the feature set that you get from something like JavaFX. It's an awesome API. It's got great capabilities. It's the language that you're used to. It's got really good tooling. All the things that you could possibly want.
Yeah.
It's a great use case, and we get a lot of traction from people who are in those sort of cases. But in the consumer cases where you're trying to run inside of a browser, I mean, regardless of what job we do on the plugin, if we get our act together and we had an awesome plugin, it's still going to be a hard sell because people don't like plugins in their browsers. It's just the trend of the industry. But when you're talking about these sort of applications, and,
or through the Mac App Store,
App Store, yeah.
Hopefully we'll have examples of the Windows App Store. So I think the App Store world is really opening a lot of doors in that sort of way as being replacing the web as a distribution mechanism for applications.
Obviously phones, tablets, but also any of the embedded devices, all perfect use cases for this sort of technology. So we would do really well in those areas.
We're
we're
well out
over.
of time.
I know. But that's okay. They stole 5 minutes from us, and it's just lunch, right? But, anyway.
Anyway, thank you all very much for coming. And,
Yep,
if
appreciate
you have any
it.
more questions, come and find us in the corridors.